same impact, I can definitely see that being frustrating. I had it yesterday.
No, I know. Because when he has people in anatomy class, it's gone.
Really?
Yeah. I don't know why.
And most people are here. Plus,
Oh
Sydney's
yeah.
like never here anymore.
Can't say that. Riley.
Riley, Gilmar, Kenzie, Oscar, yeah, that's four. Riley.
Yeah, he
Yeah,
was back then.
Riley,
I was kind of confused.
okay. Oh, wait. I recorded, right?
Yeah.
Okay, so your test is still going to be here's like four equations. I thought about this more too. It'll probably be like this is one you have to do, and then choose two out of the other three. So it'll still be like three out of four. That's that scenario, but there's probably one I'm going to force you to do. And this is not directly related to that, but it's supposed to help you kind of understand how derivative graphs, or derivatives in general, and original graphs are connected. So we're going to start trying to connect them in both directions a little bit. So this is an original graph, and if I asked you to sketch the derivative, how would we possibly go about that? So what does the derivative graph represent on the original graph? Slope. Derivative tells us the slope, right? So we're getting there eventually too. Not today, but we will eventually do that. So there's two spots on the original graph where I know exactly what the slope is. What are those two spots? At x equals -1, I know what the slope of f of x is. What is it? 0. So that's a point on your derivative graph. At -1, the slope of the original graph is 0, so the value of the derivative is 0. At x equals 1, the slope of the original graph is 0, because we got a horizontal. So the value of the derivative is 0. Second thing, is the derivative, is the original graph increasing or decreasing right here? Increasing. So remember from yesterday we made those number lines. If f of x is increasing, what does that tell us the derivative is true about the derivative? Greater than 0 or positive, right? So we're going to think about that. So in this section, my derivative needs to be positive. What does positive mean if we're looking at a graph? It means above the x-axis, right? So we've got to be, so I could kind of just guess here, like, okay, I know we're increasing there, I know we're decreasing there, and I know we're increasing there. And that means f of x needs to be above the axis here. Oh, sorry, f prime of x, the derivative, needs to be above the axis in this section. And again, we got this kind of like splits our number line in a sense, if you think about it that way. Those two zeros are kind of like breaking the number line up into three parts. So my derivative needs to be above the x-axis in this part, below the x-axis in this part, and above the x-axis in this part. Another thing to keep in mind, and especially, and this is usually true but not always, which those are fun rules, right? Like usually, but not every time. In polynomials, like, what power is this graph? X to the what? Not x, that'd be a line, right? It's not x squared, because squared would be a parabola. That's cubed. If we took the derivative of a cube, what power would we end up with? Squared. So, what kind of graph is squared? Parabola. So what should our derivative graph look like? A parabola. So we're starting to piece this together. I know it should be above the graph, above the axis here, below the axis here, above the axis there, and it should look like a parabola. So doesn't that kind of give me something like this? point that matches up that we haven't quite talked about yet, but this U here, I wish I could draw without drawing. Like point without drawing, like that. So right here we're making, this is curving down, right? Around here it switches to curving up. Do you agree? That point where it switches is called the inflection point, the point of inflection. And then that's also going to match up with the min of our parabola. Kind of talking ahead of ourselves a little bit here, but just start you seeing these things. Yeah. Well, if it's got arrows going down forever and up forever, like a sine curve, but I couldn't really do that. It'd be a little bit different. So like if I have x to the third, that kind of looks like this, or like this, right? So then my derivative would be an x squared, which looks like this, or like this. If I had y equals x to the fourth, it's going to look like that, or like that. In general, this is not perfect. And my derivative would look like that or like that. So I've never defined this term ever teaching this class. Every time I say it, everyone knows what I mean. Let's see if it works again. How many wiggles are in this graph? 2! How does everyone know that? Like, what's a wiggle? I don't know, but okay. How many wiggles are in that graph? 1, heck yes. So when I take the derivative, I lose a wiggle. So like 1, 2 is how I think about that, I guess. So when I take the derivative, I lose a wiggle. So basically, because you're reducing a power by 1, you lose a wiggle. Now this doesn't work with sine and cosine because there's not powers. It doesn't work with e's because you don't reduce the power by 1 when you take the derivative. But for like a straight up polynomial graph, when you take the derivative, you lose a wiggle. So like this, how many wiggles does this have? 3. That is so weird to me that like everyone agrees on that. But I don't.
It's just the
1, 2, 3.
tips.
Okay. Yeah, let's be careful with our phrasing here.
Devin, don't think about it like that.
So 3 wiggles. Hey, background task. 3 wiggles. When I take the derivative, I lose a wiggle, right? So what if I had a parabola? So if I have that, how many wiggles does that have? So if I reduce the wiggles by 1, I'll have 0. All lines are straight. What kind of line? Okay, we gotta stop saying straight line. Because every single line is straight. So wait, was there a question involved, or you just wanted to raise your hand and say tangent? Did I ask something? I kind of forgot. Yeah, I said stop saying straight lines, and then the other person said it was a tangent. I'm not really sure why. So the derivative of this, so think about it. This is like an x squared something, right? So if I take the derivative, it would be something with an x, which is this or this. It's not a frickin', every line is frickin' straight. That's not a line. It's a curve. The line is the shortest distance between 2 points. If I'm going to walk from me to Ethan, it's a line. Every line is a straight line. That's like the definition of a line. It's just redundant and annoying. It's like saying awesome Mr. Davis. Like we all know. What? You can call it a straight line. I'm like mostly joking, but I'm trying to make a point too, I guess. But hold on. So this has 1 wiggle. This is reducing a wiggle. And what's the derivative of this? What's the derivative of like y equals x? Don't say straight. God, horizontal. Thank you. So it'd be like y equals a constant, which is a horizontal. So I'm trying to show you like this is 1 wiggle. This is like zero wiggles, and this is somehow even less than zero wiggles. It's like negative wiggles or something. I don't know. Yeah. All right. So let's start over. Let's say I have y equals x squared. This is y equals x squared. So I'm giving you the equation this time. What's the derivative of x squared? I would recommend you draw it. Nice work. So, how many wiggles does the parabola have? One. And then if I were to go and talk about how to graph this, there's one point on this graph where I know exactly what the slope is. What is that x value? Zero. And what is the slope of that x value? Zero. And then that cuts my number line into two parts. One part over here, one part over here. In this part over here, what's my original graph doing? Decreasing. So my derivative needs to be below the x-axis. Negative values. Over here, my original graph is increasing. So my derivative graph needs to be above the x-axis. Well, doesn't y equals 2x accomplish that? My original graph is decreasing up until 0. So my derivative graph is below the axis up until 0. My original graph is increasing to the right of 0. So my derivative graph is above the axis to the right of 0. You're getting into concavity, which I don't want to yet. That's like the slope of the slope. I see where you're going. Right now, I'm just graphing. So like this. Yep. So is this red line. It's negative, becoming constantly less negative. Yes. Okay. Yes. Yeah. Yes. Again. Shut up. Correct. The decreasing on the original. So let me try and piece together what Devin was saying. Actually, this is decreasing, right? But it's decreasing slower. Like it's decreasing by really fast here, and then it starts to I'm only kind of decreasing, and then it gets to 0. So the y values on our derivative should represent that by being very negative, and that's less negative, less negative, less negative. So if I said what's the slope of this graph of the original graph right here, I should in theory be able to read up to here, read off that y value, and say, okay, maybe that's -1, let's say, and that's the slope of this blue line at that spot. Does that make some sense? So if I said what's the slope of the original graph here, here, I would read down to the derivative, read over, and I'd say, okay, maybe it's -5 down there. So you can read the slope of the original by looking at the graph of the derivative. Does that make some sense?
No.
What were you trying to
I don't know.
Yeah, that's fair.
Can the slope be so if it would be a -2x, would the slope change to the other direction?
So if I did y equals -x squared. So now, what's my original graph doing over here? Increasing, and over here, decreasing. Well, wherever the original graph is increasing, my derivative needs to be above the axis. And wherever it's decreasing, it needs to be below the axis. So now we look at this. Does that help you then?
Yeah, I got you.
Let's go another level down. What's the derivative of y equals -2. So we should be able to like make that make sense with our graphing process too. Instead of saying straight freaking line. Oh my god, that hurt my brain. So what is this red graph doing the entire time? Decreasing. So if I were to graph the derivative, what's going to be true about the values of the derivative the entire time? Negative or below the axis, right? Well, isn't that derivative negative the entire time? So it would be below the x-axis, and it would be down here somewhere. This is my y double prime. This is my y. This is my y prime. How we doing? Yeah, that's where I'm going next, but I don't want to move on until I make sure there's no questions. Oh, you want to start from the bottom? Yeah, no worries. That's integration. That's second semester. So the only thing with that is like if I said, so you'd say, what's the integral of -2? That's just like the format of it. You tell me, what could I take the derivative? This is totally separate from what we're talking about. So if you don't want to pay attention, just shut up ears for a second. What can I take the derivative of to get to -2? Is that it? What about that? Is that derivative still -2? What about that? Is that derivative still -2? So when I'm going backwards, I'm not entirely sure what's out here. So it gets a little bit goofy. We have to have some extra information. So I can't necessarily just go straight up like that, but in general, that's the same process. Alright, we're getting off this. Okay, but I'm not done. I got one more color left. I got one more level left. What's the derivative of -2? 0. Well, the derivative represents slope, right? What's the derivative of this black line, this black straight line, the entire time? It's 0 because it's horizontal, right? So like somehow in this wiggle world, being a wiggle less than a horizontal at -2 is a horizontal line at 0. So what's the derivative of that line look like? That line. You just now you can just like you're there forever. But this process, when you lose a wiggle like this, again, it only works with polynomials. It doesn't work with sine, cosine, e, any of that stuff. What? I thought you were just gonna say tangent. I'll make this bigger. I literally just said so I'm gonna make it bigger. I spoke words. So earlier in the year, I told you the derivative of sine was cos, and you all just believed me like idiots. You weren't like, how do we know? Maybe I was lying. You're like, whatever. It doesn't matter. So let's graph sine of x, and let's like talk through our process and graph the derivative. Make sure. I'm gonna try. But I didn't do a very good job. So if I'm just graphing sine of x, what's the sine of 0? What's the y value at 0? pi over 2 is 1, that's 90 degrees. Sine of pi, so now we're like over here, 0. Sine of 3 pi over 2, so now we're like straight down, so -1. So then I can like connect these and make a sine graph. Whoops. So that's sine, yes? It's a little bit like crooked, but it's fine. It's a curvy curve. That's what saying straight line is. It's a curved curve. So it's got infinite wiggles. So no, that's what Matthew said is correct. I have infinite wiggles in the sine graph. So if I reduce it by 1, I still have infinite wiggles. That doesn't really help me for this graph. So you can't think about the wiggles thing unless it's polynomials. X squared, x cubed, x to the fourth, that kind of thing.
Oh, okay. So no straight line. Leave, Ryan.
Okay, so if I were to graph the derivative of this, where on this graph do I know exactly what the slope is? There.
Negative pi over 2. Pi over 2. 3 pi over 2.
Okay. The steepest the slope ever gets is 1 or -1. So if I were to start graphing the slope, like right here, the scale is a little wacky, but right here your slope of this is actually -1. So the derivative needs to be -1. And that tracks because what is the original graph doing in this entire, like between my hands here? Decreasing. Well, when I start to draw and connect these red dots, where am I going to be? Below the axis. Doesn't that make sense? If the original is decreasing, our derivative should be below the axis. So right here, the slope is actually 1. And again, that tracks because in this portion, the original graph is increasing, so my derivative should be above the axis. And if you're getting into the next level stuff, which we're not quite there yet, but you see how right here is like the steepest slope there is? And it's also where it flips from like curving down to curving up. That matches up with the mid. And same thing in the next one. So I'm curving up and then curving down, and that change happens right here, and that's also the steepest slope. And that matches up with this peak right here. That's a point of inflection. Yep. So if I keep going with this, well, what did I just graph? That's cosine. So the Wiggles thing doesn't work, but you see how those two are related? So just help practice it again reading these. If I were to say, what's the slope of sine of x here? Yeah, first of all, positive or negative? Negative, and it would be exactly this y value, whatever this is. What's the slope of sine of x right there? -1, because it matches up right here. What's the slope of sine of x right here? 0, because the y value of the derivative is 0. Try to draw the derivative of cosine of x. It's going to be a curvy curve. Yeah, so I'm asking you to do y double prime. But you gotta know algebraically, what's the derivative of cosine? Negative sine, so that's what your graph should end up looking like. the slope of that. So the slope of that, this red actually turns around here. So the slope is 0 here, 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 and here. What is the red graph doing in this interval? Decreasing, so my derivative of the red graph versus my black graph needs to be below the axis. And then I follow through that same pattern. That's negative sine of x. Got one more. If I take the derivative of negative sine of x, it's negative cos. No. Yeah, I mean, I can just do it up here. I don't know how you're putting all that on one graph. So you're taking the derivative of the black one now. Yeah, you can almost fill in like the spaces in the graph. You always start with where do you know the slope is 0? That gives you like your critical points and you can work around with those points. It should basically fill in. You see how there's like a gap here and a gap here and a gap here? It should like fill those in so everything's nice and symmetrical. So I know the slope of the black graph is 0 here, 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 here. In this portion, the black graph is increasing, so I need to be above the axis. And once I get 1, I can kind of start filling in the rest of the way. So everything's nice and symmetric. That's pretty cool. If I took the derivative of negative cosine, where would I end up? Sine. And then I'm just like right back. It's just a pattern. Like right back where you started. So like you're never really going to be asked to do that, but I'm trying to use this to just help you understand how it fits together and how to graph. Is it working? Is that helping? I don't want to erase that. Let's save it. Well, let's see if I can save it. Saved. Wonder where that went. Okay. We hand out our worksheet. Tangents and tougher animal because you got it's just you're saying the graph though, right? Like the tangent graph goes like this. So it's always increasing, except for the asymptote, so it'd be like above the it would look like this. I believe. Which would be secant squared, yeah. Where did I leave off? Yeah, it's multiple choice graph, so it just takes a lot. There's actually a question. Just there's a ton of paper. these with you. I mean, you might be good, you might not, but if you're not, you can wait a second. I'll do a few with you to get you rolling. So I've never seen them make you sketch your graph on like the free response. So it's almost always multiple choice. I don't want to say always, but almost always. So your job is to just it's multiple choice. So pick which derivative. So basically, do a similar thing what we did. I don't think I would use this graph over here unless you want to. But I would look at this graph and say, where do I know the slope is 0? I know that the original graph is decreasing prior to 3. So where does my derivative need to be? Below the axis. And after 3, I need to be above the axis. And this is a parabola. So that's a polynomial. That's x squared. So I should have one less wiggle. What's one less? I don't want to ask this question either. What's one less wiggle than a parabola? Straight line. So you want a line that starts off down here, goes up through that point. So that's B. Does that make sense? Yeah. So that actually has 3 wiggles. So your the level above that is 4 wiggles, which is so it's either this or this. Give me a second, I can tell you which one. So it would be this one. Because that's increasing at first, and we're above the axis at first. It does in a sneaky way. I wouldn't worry about it. It's kind of like number 2 is really similar. I'm going to skip past that one. Number 3 is really similar. I'm going to skip past that one. So let's go to 4. If you're with me. You can just start going on your own, too. If you're with me, I'm going to 4. That is 2 wiggles, so our derivative should have 1. So it's got to be A or C, right? And then in the first portion of the graph, like the most left-hand portion, are we increasing or decreasing? Decreasing. So our derivative needs to be. Why am I waiting? It needs to be below. It needs to be on the bottom. So it's got to be it. Is that correct? So like right here in A, it is above the axis. It's just like barely. It's hard to tell. Asymptote ones get a little. Let's go to 7. Those are a little trickier. So first of all, if you've got an asymptote on the original, you've also got an asymptote on the derivative. So it's not going to be C or D. And then you're just playing like the increasing, decreasing game. So in my first section over here, on the left, is the original graph increasing or decreasing? Increasing. So my derivative needs to be above the axis, on the top. So it's B. How are we doing? Give me thumbs up, down, sideways. Don't flip me off. Okay, cool. What is 1, Matthew? What is it? Ethan said 5. Matthew said 1. Yeah. I would worry. You don't have to draw it. You just gotta pick. You just gotta pick it. No. So on the test, you're gonna have like the points that we find through all our work to connect, and the graphing will be easier. This is supposed to help you do that eventually, but I'm not worried if you can like get the precise graph on this worksheet. Can you get the right shape?